Another major choice of concept was the coordinate system. Cylindrical and polar type of robots already existed. Could you elaborate further, Björn, what your main choices were?
Yes, I certainly can, because that was an important question at that time. You know, there are many ways you could build a mechanical robot, and why build it in this way? If you think about the other alternatives, to have a polar type means you're going to have a telescopic arm that is going to expand its length, and that can create inaccuracies. To have a cylindrical, you're going to have an arm that goes up and down like this. So if you're going to move a small weight there, it will be a big arm at the same time. This is a very compact solution. We call this the anthropomorphic, which means human-like. And if you see, this kind of design, and you compare it with my arm, you see it has basically the same kind of geometry. It is very lightweight. It is very stable, it's accurate, it has no sliding motion, and you can also put some mechanisms into the arm, and it becomes very well protected. So we liked it very much, and that's what we picked, and others have been designed later on, but basically according this principle.
What about the transmission issues for the different axes?
Okay, let's talk about this, and luckily we happen to have a robot here, so we can show you. 3 of these are harmonic drives. That is a main, very compact kind of transmission that can have a very big exchange ratio, and that was natural, and actually the only solution that we could have in the robot. For some of the axes. On the main axis for the arm here we use ball screws, and you see that solution here. Very good possibilities also to avoid backlash, and it becomes a rather safe, dependable motion. And then of course this is not complete unless we add also our own invention in this, because we managed to invent and patent, in fact, this parallel link system. I'll show you by turning the robot here. That gives you on the inside here, not the chain or some kind of a band, but instead a steel link system, a little bit like a drawing board, where we were able to patent this area. And you can see how that provides the connection from down here where the motors are, up to this link, and further on into the wrist. As you know, this is a 2-axis wrist, and the 3-axis wasn't yet in the original design. But all those transmissions were quite modern at that time, and they still function very well. They have a very long life, very dependable, and they don't require much maintenance. So we feel that was a good solution. Still is.